Hi, grade 11. So today is lesson 8.2 and 8.3, which is about compound interest, building off our lesson the other day about simple interest. So there's a handout on Teams that you should print out and fill in as you watch this video. So at the top of the handout, there's a box that says key ideas. And first it says compound interest. Interest is added to the principal before the new interest is calculated. So in other words, you earn interest on your earned interest. Interest is paid at regular intervals called compounding periods. So to determine the total amount, A, of an investment or loan after a certain length of time, you'll use the equation A equals P, bracket 1 plus I to the power of N. To determine the value that would need to be invested now, the principal, to reach a desired future amount, A, you'd use P equals A over 1 plus I to the power of N, which can be rewritten as P equals A 1 plus I to the power of negative N. Remembering the negative exponent rule can do that for you. For every compounding interest scenario, the interest is given as an annual amount, but must be divided into the number of compounding periods per year. The total interest is dependent on the total number of compounding periods. So this table here just summarizes some common scenarios that you can easily refer to. So annually means once a year. The interest rate is just I in a decimal form. N is the number of years. Semi-annually means twice a year. So you'll take the interest rate as a decimal, divide it by 2. And then the number of compounding periods is just the number of years times 2. Quarterly, 4 times a year, interest rate divided by 4. And number of compounding periods is years times 4. And then monthly is 12 times a year, divide the interest rate by 12, and multiply the number of years times 12. So, some examples. Find the interest rate for each conversion period and the number of compounding periods. So, A, investment at 6% per annum, compounded annually for 5 years. So we'll start with the interest rate. So the interest rate is 6% per annum, so 0.06 as a decimal. And it's compounded annually, so we divide it by 1 because it's just once a year. So that's just 0.06. The number of compounding periods, well, it's for 5 years times how many times per year? Just once per year. So there's just 5 compounding periods. That's the most straightforward. Letter B, you have a loan at 6% per annum, compounded monthly for 3 years. So now we have our interest rate is 6%, so 0.06. But now it's being compounded monthly. So that means we need to take this yearly interest rate and divide it by 12. And that is 0.005. And then the number of compounding periods, it's 3 years times how many times per year? Well, it's every month, so that's 12. So there are 36 compounding periods. Letter C, we have an investment at 4.5% per annum, compounded semi-annually for 42 months. So interest is 4.5%, so 0.045. And this is compounded semi-annually, so that means twice a year. So we'll divide it by 2, and that is 0.0225. And then the number of compounding periods, this one is a little trickier because that's always done yearly, but now it's 42 months. So we need to do 42 months divided by 12 to get it into years, and that equals 3.5 years. And then it's compounded twice per year, so times 3.5 by 2. So there are 7 compounding periods. Okay, number 2. If $4,000 is borrowed for 4 years at 3% per annum compounded annually, find the accumulated value of the loan. So let's write the details that we know. So the amount, we don't know. The total amount, we don't know. The principal, $4,000 was borrowed, so that's $4,000. The interest is 3% per annum, compounded annually. So first we'll write it as a decimal. It's compounded annually, so that's just once per year, so 0.03, that stays the same. And then the number of compounding periods, n, is 4 years and once per year, so just 4 compounding periods. Now, we need to find what a is, so we're going to use that first equation in the box up there. So a equals p bracket 1 plus I to the power of n. So a equals, principal was 4,000. 1 plus the interest rate is 0.03. And n, the number of compounding periods, is 4. So let's simplify this a little bit. In the bracket there, 1 plus 0.03 is 1.03 to the power of 4. So according to BEDMAS, we do exponents next. So 1.03 to the power of 4, type that into your calculator, and then times 4,000. And the total will be 4,502.04. So I think the most important thing to remember here is that you're not doing 4,000 times 1.03 and then all to the power of 4. Only the 1.03 is to the power of 4. And then multiply that number by 4,000. So therefore, the accumulated value of the loan was $4,502.04. Okay, on to number 3. If you borrow $2,000 at 4% per annum compounded quarterly, how much do you owe after 7 months? So the amount, the total amount, we don't know that. The principal, you borrowed $2,000. The interest, 4% per annum. And now it's compounded quarterly, so that's 4 times a year. So we need to divide the interest rate by 4. So that's 0.01. And then the number of compounding periods. So how much do you owe after 7 months? Well, 7 months is 7/12 of a year. So that doesn't work out to a nice fraction, so or a nice decimal, so we'll just leave it as a fraction. So 7/12 of a year, and then times 4 times per year equals 28/12 as a fraction. And that simplifies to 7/3. So 7/3 compounding periods. Again, not a nice decimal, so 7/3. We will plug that into the equation where a is missing, so we want it to equal a. A equals p 1 plus I to the power of n. A equals 2,000. 1 plus the interest rate of 0.01, so 1.01 to the power of 7/3. Now on your calculator, you would do 1.01 to the power of 7/3. You might have to put the 7/3 in brackets. And then times 2,000, and that should get you 2,046.98. So after 7 months, you owe a total of $2,046.98. All right, number 4. You would like to invest money in order to purchase a cottage in 8 years. The investment must be worth $128,500. The interest rate you were offered is 6.5% per annum compounded semi-annually. How much do you need to set aside now to reach this goal? So the amount, the total amount, we do know in this case because it's our goal. It's how much we want to have, which is $128,500. The principal, well, that's what we need to know. How much money do we need to set aside now? The interest rate was 6.5%, which is 0.065. And it's compounded semi-annually, so twice a year. So we need to divide that by 2. So 0.0325. And then the number of compounding periods, well, this is for 8 years, and it's being compounded twice a year, so that's 16 periods total. So now we're going to use the second equation in the box, because we know A, but we don't know P, so we want it to equal P. So P equals A bracket 1 plus I to the power of negative n. And we'll insert what we know. P equals A is 128,500. 1 plus our interest rate of 0.0325, so 1.0325. N is 16, so to the power of negative 16. So first type in 1.0325 to the power of negative 16, and then multiply that by 128,500, and you will get $77,030.40. So that means, therefore, you need to set aside $77,030.40 in order to reach this goal in 8 years. All right, number 5. Today, Larissa has $7,424 in her bank account. For the last 2 years, her account paid 6% per annum compounded monthly. Before this, she received 6% per annum compounded semi-annually for 4 years. If she made only one deposit 6 years ago, how much was it? Okay, so this is going to be a multi-step problem. First, we need to calculate how much money she had in her account 2 years ago. And then we need to calculate how much money she had in her account 4 years before that. So what do we know right now? The amount she has today is $7,424. The principal, we don't know, and this is going to be 2 years ago. The interest rate for the past 2 years has been 6%, so 0.06, and that was compounded monthly, so that was 12 times per year. So divide by 12 is 0.005. And that was 12 times per year for 2 years is 24 compounding periods. Okay, so in this case, we need to find P, which is the principal, so we're going to use the second equation with a negative exponent. P equals A times 1 plus I to the power of negative n. So P equals 7,424, bracket 1 plus 0.005, so 1.005 to the power of negative n, which is negative 24. So do 1.005 to the power of negative 24, and then multiply that number by 7,424, and the answer is 6,586.47. So this is the amount she had in her account 2 years ago. Okay? Before that, her interest rate was something different, so we need to calculate that separately. So now we're going to do this again with the amount we just calculated. So the total amount 2 years ago was 6,586.47. The principal, what she invested 4 years before that, we don't know. The interest rate for those 4 years was 6%. But instead of being compounded monthly, it was compounded semi-annually, so 2 times per year, which gives us an interest rate of 0.03. And the number of compounding periods, that was for 4 years, and it was compounded twice a year, so that was 8 periods. So we're going to use that same equation. P equals A, 1 plus I to the power of negative n. A is 6,586.47. The interest rate is 0.03, so 1.03 to the power of negative 8. Do 1.03 to the power of negative 8, and then multiply that by 6,586.47, and you will get 5,199.42. So therefore, 6 years ago, she deposited $5,199.42. All right. Okay, that wraps up the lesson. Let me know if you have any questions, and have a good day.